Today we're going to talk about some material out of Unit 2, boxes D and E. We're going to look at first how you multiply powers and divide powers, and then we're going to look at how you evaluate powers of powers, or powers that are raised to some exponent. Okay. And the easiest way to approach this is to just express this in terms of some laws. Okay? So the first law we're going to look at is our law for multiplication. And we'll just state the law first, and then we'll look at a few examples to see how it works. When multiplying powers with the same base, here are the steps that we follow. We keep the base the same, we add our exponents together, and we multiply the coefficients together if we have any. If there are any. Okay? So what do I mean by this? Well, let's say we have a question that looks like 2 to the exponent 3 times 2 to the exponent 5. Okay. This rule tells us that what we want to do is we want to keep the base the same. So what is our base here? Well, our base is 2. So we're going to keep the base the same, and we're going to add our exponents together. So our first exponent is 3, our second exponent is 5. So our new exponent is going to be 3 plus 5, or 2 to the exponent 8 is going to be our final answer. Now, why does this work like this? Well, remember, we could take each of these powers and we could write them in expanded form. So 2 to the exponent 3 was really 2 times 2 times 2. 2 to the exponent 5 is really, I'll put brackets around that, so that's our first one. 2 to the exponent 5 was really 2 times 2 times 2 times 2 times 2. 2 times itself 5 times. Well, in total, how many 2's do we have there multiplied together? We've got 8 of them. So this whole thing we could write as 2 to the exponent 8. Okay? So when multiplying, keep the base, add the exponents. And it works equally well if we have a variable as our base. We see something like this, x to the power of 7 times x to the power of 4. First, we check to see if the base is the same. If the base is the same, we are going to keep the base, and then we're going to add our two exponents. 7 plus 4 is 11. So we get x to the power of 11. Now, what if we have something like 2 to the power of 4 times 4 to the power of 2? How do we evaluate this one? What do you think, Stephanie? Nope, it's a trick question, okay? What was the first rule up here? They got to have the same base, okay? So something like this, we can't evaluate using this rule because here we've got a base of 2. Here we've got a base of 4. So we can't use this rule. Now, what we could do here is we could punch this into our calculator, figure out what 2 to the power of 4 is, figure out what 4 to the power of 2 is, and then multiply those numbers together. But we can't use that rule unless they have the same base. Okay. So let's try something a little bit trickier here. What if we have something like 2 times x cubed and 4x squared? Okay, so now we've got powers of x with coefficients out in front. We call that number out in front the coefficient. Okay. How can we think about these ones here? Well, the way to think about it, I think, is to say, this is basically 2 times x cubed times 4 times x squared. So let me just write that out. So it's 2 times x cubed times 4 times x squared. Okay. Now, because all of these things are multiplied together one after another, it doesn't really matter what order we put them in. Okay? So I'm just going to rearrange them a little bit and put the numbers together and the powers together. So I'm going to turn this into 2 times 4 times x cubed times x squared. Oh, that's not an x squared, that's an x cubed. Okay. And now I can sort of think about this in parts. I can look at my numbers, and I can look at my powers. So if I multiply those two numbers together, 2 times 4, what am I going to get? I'm going to get an 8. That 8 is going to be my new coefficient. And what if I multiply x cubed times x squared? Well, let's see. Powers of the same base. What's my rule here? I'm going to keep the base. What's my new exponent going to be here? It's going to be 5. I'm going to add these two exponents together. I get power of 5 there. Okay. We'll do one last one here. This one's a bit trickier. Two x squared, y to the power of 5, times negative 6, x to the power of 4, y squared. Okay. Now, when you get really good at these, you won't do this intermediate step here where you sort of rearrange everything. But for now, let's just try rearranging it again, putting sort of things that look similar next to each other. So I've got two numbers first. I've got 2 and negative 6. So I'm going to do 2 times negative 6. What other things am I going to sort of group together here? What looks similar? What do you think, Liam? So my powers of x here, x squared and x to the 4th, I can put them together. And what else can I put together here? All right. And now I can combine them together. 2 times negative 6 gives me negative 12. These two have the same base. Base is x, so I can keep the base, add the exponents. Y's have the same base. I can keep the base, add the exponents. Okay. Now, can I combine these two together? No, I can't, because they have different bases. One has the base of x, and one has the base of y. Okay. And that's how we multiply powers together. Now, division is going to be very, very similar. Okay. So again, we'll start with the rule, and then we'll look at some examples here. So when dividing powers with the same base, again, we keep the base the same, but instead of adding the exponents, we subtract the exponents. And then instead of multiplying our coefficients, we divide the coefficients, again, if we have any. So we'll start with one that just has numbers here. Okay. We've got 8 to the power of 7 here, divided by 8 to the power of 5. We want to, first, we check to see if our base is the same. And yeah, we have the same base. It's 8 in both cases. So we're going to keep that base the same. Okay. And to do our division, we are going to subtract our two exponents. So our new exponent is going to be 7 minus 5, or, final answer, 8 to the power of 2. Okay. And of course, if this is all numbers here, we could simplify this even further to 64. Okay. We could have something like this: y to the power of 9 divided by y to the power of 2. How are we going to simplify this a little bit here? What? Go ahead. How are we going to simplify this? How can we apply this rule here? We're going to divide them. Yep. So we could, you're right, you want to rewrite this as this. Okay, that's an optional step. And then where do you go from here? Okay. And that becomes our new exponent. And what's our base going to be? It's just going to be y. So what's our final answer going to be? Y to the power of 7. Okay. So try one here that's a little bit more complicated. 18 x to the power of 4 y cubed divided by 6 x squared y cubed. Okay. When you see one like this, it's useful to write it so that the things that have the same base are lined up over top of each other. So I've written my x to the power of 4 over my x squared, my y cubed over my other y cubed, and I've written my two coefficients, 8 and 6, over top of each other. Because it's pretty easy to see sort of which terms are going to match up together. So let's start with these terms that have base x. Okay? If we divide x to the power of 4 by x to the power of 2, what are we going to get? Well, same base, so we're going to keep that base. What are we going to have as our exponent? 2. Okay. What about our y here? Okay. We've got y to the power of 3 divided by y to the power of 3. I'm going to keep that base y. When I apply the rule here, what do I get for my exponent? Emerson? Yeah, 0. Okay. Now, usually when we get something to the exponent 0, like anything to the exponent 0 is just 1. Okay, so we don't actually even write that. So I'll put this over at the side. Anything to exponent 0 is 1. Okay. What about our coefficients out front here? We've got 18 divided by 6. What do we get when we do 18 divided by 6? 3. So that's going to be our new coefficient, 3. So our final answer here is going to be 3x squared. All right. Let's try one last one here. 2n to the power of 7 divided by 8n squared. Okay. Okay. First, we ask ourselves, do we have the same base here? What do you think, Aaron? Do we have the same base? Yeah. So what are we going to, we're going to keep that base, and over here, what are we going to have for our new exponent, Aaron? 5. 7 minus 2. What do we do with these two coefficients here? Okay. We want to divide them. Okay. So if we divide them, what do we get when we do 2 divided by 8? Well, we're going to get a fraction, right? Our fraction is going to be 2 over 8. So we just want to put this in lowest terms. So we want to look for something that divides evenly into both 2 and 8. We can divide each of these by 2. So our final answer here is going to be 1/4 n to the power of 5. I'll just say put in lowest terms. So multiplication and division. Okay? One last rule to take a look at. And that's what this is what you do when you have a power that is itself raised to another power. So here I've got 3 to the power of 4, and then I've written that to the power of 2. Or over here I've got 3x to the power of 5, and then all of that is to the exponent 3. Okay? What are we going to do with this? Oh, and this should be box E here. The way to think about these ones is, think of everything here in the brackets, okay, that 3 to the power 4, as the base for our exponent 2 here. So what does this exponent 2 mean? It means take the base and multiply itself 2 times. So we can think of this as 3 to the power of 4 times 3 to the power of 4. Okay. Our base multiplied by itself. But we know how to evaluate that because we've got 2 powers with the same base. So how do we multiply 3 to the power of 4 by 3 to the power of 4? Well, what's our new base going to be here? Andrew? Do we multiply the bases? We're not going to divide it either. If they've got the same base, what do we do with that base? Okay, so what are we doing, Andrew? Keep the base the same. Add the exponents. 4 plus 4 gives us 8. Now notice that our new exponent here, 8, is the same as these 2 exponents multiplied together. Okay. Let's see if this pattern holds over here. Here we've got 3x to the 5 to the power of 3, so we can think of this as 3x to the power of 5 times 3x to the power of 5 times 3x to the power of 5. I can apply my rules for multiplication here. I'm going to keep the base the same because they all have the same base of x, x, and x. And what is my new exponent going to be here? 15. And I got these 3 coefficients here, 3, 3, and 3. If I'm doing multiplication, I want to multiply all of those together. So 3 times 3 and then times 3 again is going to get me, let's see, 27. Okay. Now notice, again, our new exponent here is 5 times 3. Our 2 original exponents multiplied together. Also notice that our new coefficient here, 27, is 3 times 3 times 3, or 3 to the power of 3. Okay. So, here's our rule. We can simplify a power of a power, or a power raised to another exponent, by keeping the base the same, multiplying the exponents, and then applying the exponent to that coefficient. So here our coefficient was 3, so we can apply that 3 to that base of 3. So how is this going to look if we've got something like x to the power of 4, then raised to the power of 6? Okay. What's our base going to be in our new power? What do you think, Liam? Our base is going to be x. How are we going to get our new exponent here? Chris? 4 times 6, yeah. And we just multiply that out. So it's going to be x to the power of 24. Okay. If we've got something like negative 2y, and let's make this y to the power of 4, that whole thing cubed, what we have to remember is that this 3, this exponent, applies to that negative 2 and to this y to the power of 4. So we can think of this as negative 2 to the power of 3 and y to the 4 to the power of 3. Let's do y to the power of 4 to the power of 3 first. What's our base going to be here? Liam? And what's our exponent going to be? Well, Liam? Multiply them together, so we're going to get 12. What's our new coefficient going to be? Well, we're going to take the negative 2, we're going to raise it to the exponent 3, so this is negative 2 times negative 2 times negative 2, which is going to give us negative 8. So our final answer here, negative 8y to the power of 12. Okay? And those are the 3 rules you need to know. How to multiply powers of the same base, how to divide powers of the same base, and how to take a power and raise it to another exponent. And I'm going to